Okay, oh, I forgot. We ended here where it says, let me fix our note so we can see it nice and pretty. Is with the end point. Alright, so I need you to finish the notes, the second part, which is really much going to be the second page. There's some guided practice or independent practice for you to do. Remember, this little side note is just lines that do not intersect may or may not be coplanar. They may or may not be in the same plane. But on the second page, I'm hoping this is a familiar term for you. This is not the simple one. Parallel lines basically are coplanar lines that do not intersect. Now, we have a symbol that we use in geometry to represent parallel lines, and it's a symbol you need to get familiar with. We have also a symbol for perpendicular, and that is right here, math reading tips. If you know, we have line AB because that's the line symbol above the two segments, and right here, these two bars side by side, basically this is our symbol for parallel. Oops, excuse me. So instead of writing the word, you're going to see me write those two lines, vertical lines, to represent parallel. So if you see this, it is read as line AB is parallel to line EF. Now, I have this little gizmo I kind of want to show you, and I'll try to have it running So we have here our parallel lines on the same plane, so they're coplanar. And what they wanted you to see is that no matter how I rotate this, okay, they're never going to intersect, all right? Now, I can add a new plane here. Oh, it's not going to let me do that. Can change my lines like that. Parallel lines. These two parallel lines are coplanar. They never intersect. Now, when I talk about skew lines, which is the next example, and I'm going to show you that right here. Now, look at these lines. Look what's happening between them, okay? One, they're not coplanar, okay? They're not on the same plane. That's the key component to making sure we have the right understanding. They are not parallel, okay? They're not parallel, and they will never intersect if you look at this. So to be skew lines, you're not on the same plane because you have one that's on the plane and one that's not on the plane. It's going through the plane. And if I had a line intersect a plane at one point, that's what we have. And so you can have non-coplanar lines that are not on the same plane, that are not parallel, that do not intersect. And that is what we call skew lines. And hopefully understanding this is going to help you with your Kleenex box activity tomorrow. So here, and I'm going to give you a little time, you can pause the video. I wanted to see if you can identify parallel and skew lines using the rectangular prism that we have at the right. So answers are going to vary. There's more than one answer. I'm going to try to get as many up here as possible, but just pause the video, see if you can answer these 4 questions. All right, so if I want a line that is parallel, the first one is that intersects segment AB. That's this edge right here. So we want lines that would intersect that segment. Well, I could have, if I wanted to start right here in the front, AT, this segment would end up intersecting AB at A. So I could have segment AT, okay? I could have also, if you look on the other side over here, it would intersect that segment AB at B. So I could also have BK. When it intersects, it does not have to intersect at the end point. So another line I could use, and I'm just going to highlight it, even though it intersects at the end point, is line AC. Okay, so I could also include AC. If I wanted to, even though it's not drawn, I could add this line from H to A, and it eventually would intersect that segment. So do we see how the answers could vary here? Okay. I could also have BC. did KB or BK. We could also have a line from drawn on the opposite corner, like such, BG. Okay, line segment BG. And then they went all, for B, they went all the segments that are parallel to KG. So I am going to just highlight that. KG, right down here. We want all the lines that would be parallel to KG. So that means it never intersects and it's on the same plane. So I'm hoping you see straight off the bat we have this right here. Oh, no, actually want the segment. So TH, that would work. You could also have BC. BC is on the other side. It's right above it. It would be parallel using the back face. And when we have parallel lines, I think I mentioned this on the last video. To show it's parallel, on a figure, you have to see the arrows. So, and if lines are parallel to each other, they have the same arrows, same amount of arrows. I could have two, but I would have, as soon as I show that this one has a different marking, it's saying that it's not parallel. But I would have to have two arrows to show that they're parallel. So we have T, H, B, C, and the last one is up here, AD. All right, now they want us to name all segments that are skewed. That goes back to the little example I was showing you. Oops, sorry. Okay, skew, non-coplanar, not parallel, do not intersect. Okay, so we want skewed to TK. Skewed to TK. So if I look at TK, hopefully we agree it's at the bottom face. Okay, so for it to be skewed, sorry for that. For it to be skewed, we will need to not be on the same plane. So it cannot be on this bottom plane, and it cannot be on this side plane, and it cannot be parallel. Okay. Now the key to this, and it cannot intersect. So the key to this is think of the direction that TK is going, and I want to pick up a line segment that is not on that plane, but is going in a different opposite direction. I kind of look at this as horizontal, you know, kind of coming out to you. So the opposite of horizontal would be vertical. So to get a skew line to TK, I want a line that would be vertical to TK. So a good starting point would be right here. I can go, we can see that those two line segments would be skewed, non-coplanar, not parallel, and do not intersect. So G, C. All right, so let's think of another one, maybe similar to that. I can't go to BK because it would intersect it. So I could just move to the front. And same thing, non-coplanar, do not intersect, and they're not parallel. Now I want you to see if you could come up with the remaining. There are a total of 5 skewed lines. So, and possibly a little bit more if I look at diagonal lines. Like there's one shown right now. So if you see TK, right now, AC is skewed to that line. Because they're not on the same plane and they will never intersect. So I want you to try to come up with at least 2 more. At least 2 more, okay? Now, name all planes that intersect plane DCG. Now we kind of did this on the other set of notes. And the way I kind of hope give you a visualization to help you see it, follow the letters in order. So D to C to G would have to be this parallel, this plane here, the face, the right face. And we want a plane that intersects that touches that plane. Now when we name a plane with 3 letters, 3 non-coplanar points. And so if it's intersecting, it's got to touch this edge here. So one of them, well, more than one, would be ABC. Okay? This would be identifying a plane. I could do the parallel symbol to show a plane as well. But since we're dealing with a rectangular prism, I know that has to be a face. So another one I'm hoping you can see, I could do the bottom one, TKG or TKH or one combination of that. So I'm hoping that you will list at least 3 more of these as well, okay? 3 more, and we're going to check this in class. So that's one of the things I'm going to check for. Now, the next section we're about to get into is measuring segments, the 1.2. Oh, I forgot, parallel lines, or parallel planes. Well, if you know parallel lines, lines do not intersect, so it's just planes that do not intersect. So that was pretty simple. Now, measuring segments, ruler postulate. What you need to understand with the ruler postulate is that for every coordinate, every point on a number line, so what they're trying to show you right here is point A corresponds with this coordinate right here, A, some value, some real number, 5, 6. And the same thing happens. They correspond. For every point on a number line, okay, paired to a real number, so that's why I say real numbers, corresponds to a value. And therefore, if I know that, the distance between them would have a value as well. So if I look at the length, I talked about this yesterday in class, or today in class, so I said the length of AB, length, we don't have to put this symbol anymore. Okay, this is a segment without its length. To find the length, I'm looking at the difference between the A coordinate minus the B coordinate. I could count if I wanted to, okay, but if I just take the difference between them, that would represent the length. So it's the absolute value subtracted difference amount, meaning that the distance will always be positive. Absolute value, if I have the absolute value of a -3, it's going to be a +3. Just like the absolute value of a +3, it's still going to be +3. I think the absolute value because distance is positive. So I know you're pretty already familiar with this, corresponding the point on the number line and its distance. Since we don't have any segments above these letters, I'm asking for the distance. So on this first one, they want the distance from R to S, because R is between a -4 and a -3. We could say R is at a -3.5, okay? So if I was going half a unit, then another whole unit, and another whole unit, the distance between R and S would be 2.5. Or if I do the coordinate of R is a -3.5 minus the coordinate of S, which is a -1. I take the absolute value of that, well, that now becomes plus. So -3.5 plus 1 is going to leave me with a -2.5. And absolute value is always positive, so that is 2.5. Our distance answers are always going to be positive. So I want you to go ahead and try to find the distance of ST and RT. And just remember that mucho importante. No signs above the letter means to find the distance. When you find the difference and then take 2 positive numbers, the distance or length must always be positive. It's always going to be positive. So the measures found above show a relation. When one point is between 2 other points, sorry about that again, all points are collinear. That means they have to lie on the same line. That was horrible. All right, so what we're going to get into tomorrow, and we're going to start on this after our activity, is segment addition. What the key thing with segment addition is we got to have a point between 2 other points, but all 3 points are collinear. So you know the example they said, if Q is between PR, then I can take the parts PQ plus the part QR and get the whole PR. And same thing, if PQ plus QR equals PR, then I know Q is between. The key part to this, whenever you see between, you're going to be doing segment addition. So every time I see between, I'm going to be adding when I see that word. And so what we're going to learn and what we're going to practice and apply is taking the given information that is in the problem, so it says if AB is equal to 3x plus 2, and that's the length of AB, the length of that segment, okay, the distance between A and B, and BC equals 18 and AC equals 5x, determine AC. Well, the first thing we're going to do is, if they give us information and we have a figure, you always label first. So I'm going to put the 3x plus 2 between A and B. I'm going to put 18 between B and C. And A to C, from A all the way to C, that's 5x. So I'm just going to add that, 5x. And now I can see that all 3 points are collinear, okay? They all lie on the same line. And I see B is between the two of them. So then I would start off with my GE, is what I call my geometric equation, using my postulate. And that means I could add the segment AB, that part, plus BC, and that would equal to the whole segment AC. Okay, so the distance of AB plus the BC would equal to the whole length of AC. And then from there, now I can substitute my values for each part. I know AB, is the 3x plus 2, because that is this segment here. And then BC, that would be plus 18. Okay, so those two parts together make the whole segment, which is 5x. And then now we're back into algebra skills, our prerequisite skills that we were checking on the review packet. So from here, we expect you to combine like terms, solve for x. Now, we want you to use what you know about collinear points, what we know about between, like on this number 5 again, is between. So between whenever I see a point is between another 2 points, we should think, what postulate could we use to set up our relationship? All right, so we're going to stop right there. Thank you for taking care of this. Hopefully, don't forget your Kleenex box. Let's get ready to get this done. All right, thank you. Bye.